Hello everyone, in this video we will learn the chromatographic separation process inside a column. First, a column or tubing is filled with packing materials, which are illustrated dots on the diagram, and stay inside the column during the separation process. These materials are called stationary phase for column chromatography. An analyte mixture, illustrated as the dark band, is then loaded onto the top of the column. Following that, a solvent is then poured onto the top of the column and gradually brings the analyte mixture down the column. The moving solvent through the column is called the mobile phase for the column chromatography. Because different species have different migration rates due to their interactions with the stationary phase, the different analytes inside the analyte mixture will be separated into different bands. In this case, I'm using a mixture of two components, red and green, as my example. Green band moves faster than the red band. Therefore, the green component is separated from the red component. The separation process of two analyte bands inside a column is called column chromatographic separation. Two different types of materials can be used at the stationary phase for column chromatography. The first type is the small spherical porous solid particles. The materials that can be used include inorganic oxides such as silica gel and alumina, carbon molecular sieves, and polymers. The second type uses a liquid to coat the solid support such as inner wall or particles inside the column. The materials can be used mainly are polymers with different functional groups such as polysiloxane with different functional groups and polyglycol. Mobile phase is the solvent flowing through the column. Sometimes it is called as eluent. Mobile phase can be present in different forms such as gas, liquid, or supercritical fluid. The difference in the mobile phase differentiates different types of chromatography. For example, if the mobile phase is gas, you will have the gas chromatography, GC. Similarly, liquid chromatography, LC, uses liquid as its mobile phase. Supercritical fluid chromatography, SFC, utilizes supercritical fluid as its mobile phase. The common types of gases mobile phase include nitrogen, hydrogen, helium, and so on. The mobile phase used for LC includes the aqueous solvent, organic solvent, and even the mixture of aqueous and organic solvents. Supercritical fluid, which is the solvent under supercritical conditions, can be also used as the mobile phase for column chromatography. Now we're going to look at the process involved in the column chromatographic separation of two species in the mixture. Again, the mixture is loaded onto the column and a detector is coupled at the exit of the column to monitor the species coming out of the column. The recorded detector response as a function of time is called chromatogram, illustrated on the bottom right of the screen. X-axis is the time and the y-axis is the signal. 4 representative points, 0, T1, T2, and T3 on the chromatogram are worth of discussing here. At the beginning, the time is set as 0 and the mixture is loaded onto the separation column. Because the separation hasn't happened yet, the detector is unable to respond to any species in the mixture. Once the mobile phase is added, Due to the different migration rates of the species in the mixture, two bands, green and red, slowly move down the column, but the green band has a slightly faster migration rate, hasn't reached the detection zone at T1. The process continues, and at T2, the green band exits the column and reaches the detection zone. The detector will respond to the presence of the green band in the zone and give a signal, a sharp peak on the chromatogram. For the red band, it still moves inside the column. As a result, no signal for the red band. At T3, the red band exits the column and appears in the detection zone. This is the area when the detector responds to the presence of the red band and gives a signal, a peak on the chromatogram. The time corresponding to the presence of species is called retention time, which tells how much time an analyte spends in the column. In order to have a good column separation, different species should have different retention times. Thanks for watching. See you next time.